In the previous class, we have seen about this random process. In that, we have come across with what is troubleless process, WSS process, and many more. Now we move on to the problems. Let us see this using the problems. The very first problem, the probability distribution of the process x of t is given by the probability of x of t is equal to n, which is at to the power n minus 1 divided by 1 plus at whole power n plus 1, where n varies from 1 to 3 etc. A and at by 1 plus at if n is equal to 0. We are supposed to show that this x of t is not stationary. Okay, now let us go for the solution. What is given? The representation has been written in such a form that the x of t and their corresponding probability value. So n p of xn. So n is from 0, 1, 2, 3 etc. When the same value is 0, the probability value is at by 1 plus at. So the corresponding probability value as written as such. When it is 1, we are going to with this. So at power n minus 1 by n plus 1. 1 plus at whole power n plus 1. Here the n value, when you change this n value, we will be getting the corresponding probability value. So for n value 1, we got 1 by 1 plus at square, at whole square. When n value is 2, it is at divided by 1 plus at whole cube. Similarly, the rest of the probability values are. We are supposed to show that it is not stationary. We know that for stationary, the mean value should be constant. First, we will calculate this mean value. So, mean value is equal to expectation of x of t, which is nothing but summation of n equal to 0 to infinity, n into probability of the corresponding value. So, when n value is 0, first one is 0 and their corresponding probability value. So 0 into at by 1 plus at. Next plus 1 into 1 by 1 plus at whole square plus 2 into at by 1 plus at whole cube plus 3 into at the whole square by 1 plus at whole power 4 plus so on. So their n value and their corresponding value is product and all the values are summed up. Now here in all the terms, this 1 by 1 plus at square is common. So when we take it out, what will be the remaining terms? The first term is 0. Come to the second term. Here 1 by 1 plus at square is taken out. So 1 plus 2 into at by 1 plus at plus 3 into at by 1 plus at the whole square. So it is taken. Now you look at this terms inside the bracket. It looks like 1 plus 2x plus 3x square plus etc., which is in terms 1 minus x whole power minus 2. So it is written in such a form. So 1 minus the x term is at by 1 plus at whole power minus 2. Now if we take this LCM, this 1 plus at is multiplied here. So 1 plus at minus at whole divided by 1 plus at. So in numerator, this at and minus at gets cancelled. So one term is positive and the other term is negative. So it gets cancelled. So the remaining term is 1 by 1 plus at whole power minus 2. When you reciprocal it, it becomes 1 plus at whole square in the numerator. So which gets cancelled and you are getting that it is equal to 1, which is a constant. So we got that mean value as constant. So to prove it, the next as a not stationary, next we are going in for variances. So expectation of x square of t. So we know that summation of n equal to 0 to infinity n square into probability of xn. So here this n square is written in the form of n into n plus 1 minus n. When you simplify this, you will be getting this n square. So n square is written in such a way. This is for our convenience. Okay. So n into n plus 1 minus n into p of xn. So when you separate this, it has been separated into two summation parts. In this, the second summation is nothing but expectation of x of t, which we have already found out earlier. So we'll make use of that. Okay, so this expectation of x of t is replaced with 1, which we find it out here. Now in this series terms, you can find this 2 in 2 by 1 plus at the whole square is common in all the terms. When you take it out, the remaining terms are here 1 plus here 3 into at by 1 plus at plus 6 into at by 1 plus at the whole square plus etc. So this terms are looks like 1 plus 3x plus 6x square plus etc., which is in turn 1 minus x whole power minus 3. So this term has been replaced as 1 minus x is nothing but at by 1 plus at whole power minus 3. So we will take this LCM. So this is 1 plus at minus at by 1 plus at. So this plus at and minus at gets cancelled. The remaining term is 1 by 1 plus at power minus 3. When you take it to the numerator, this minus 3 becomes whole cube. So when you cancel this, the 1 of this 1 plus at is remaining. So 2 into 1 plus at minus 1. So when you remove this bracket, 2 in plus 2at minus 1. So 2 minus 1 is 1 plus 1. So 2at plus 1. So variance of x of t is expectation of x square of t minus expectation of x of t the whole square. This expectation of x square of t, which we find it here, so 1 plus 2at, and the expectation of x of t is 1, which we find it earlier. So 1 whole square, which is nothing but 1. So this plus 1 and minus 1 gets cancelled. So remaining is 2at, which is dependent on t. So we say that it is not stationary because this variance must be dependent of time difference only. Here it is dependent of t, so which is not satisfying the condition. So x of t is not stationary. Okay. Next, move on to the second problem. Discuss the stationary of random process x of t is equal to a cos omega naught t plus theta. If a and this omega naught are constants and theta is uniformly distributed random variable in the interval 0, 2 pi. So this is the given problem. We are supposed to show that it is a random process, stationary random. First let us share that this a is constant and this omega naught are constant. This theta is a variable which is uniformly distributed. So if it is a uniform distribution, we know how the probability function shall be defined. So let us have that f theta of theta means which is equal to 1 by 2 pi, which is nothing but if the interval has been given, we calculate the probability function by 1 by b minus a. Here it is 0, 2 pi. This is a, b. So the probability function is 1 by b minus a. Here the b value is 2 pi. So 1 by 2 pi minus 0, which is nothing but 1 by 2 pi. So we find out the probability distribution, which is uniformly distributed within the interval 0, 2 pi. Now to prove it as stationary or not, the first and foremost thing we are supposed to do it is we are supposed to find the mean value. So mean is equal to expectation of x of t, and which is nothing but since it is uniformly distributed, integral 0 to 2 pi this constant of a cos omega t plus theta into the probability function 1 by 2 pi into d theta. Okay, let us collect all the constant terms. So here the constant term is a and 1 by 2 pi, which is taken out. The remaining term is cos omega naught t plus theta. When you integrate it, we will be getting sin omega naught t plus theta. Here the variable is theta. Okay, so the limit is 0 to 2 pi. Now when you substitute the upper limit, which is sin omega naught t plus 2 pi minus sin omega naught t plus 0, which is nothing but omega naught t, okay, which is equal to 0, because this, when you replace it, this becomes sin omega naught t gets cancelled. Okay, So which is equal to 0, which is a constant. Okay. Next we are going with autocorrelation function. So autocorrelation function means R suffix xx of t comma t plus tau. We will represent t1 comma t2, or we can also represent it as t comma t plus 2. So which is nothing but expectation of x of t into x of t plus tau. So the given x of t is replaced in such a way as per the requirement. So x of t is a into cos omega naught t plus theta. If it is x of t plus tau, means in the place of t it is replaced as t plus tau plus omega naught. So here if we take this a square as taken out, so a square. Now this cos a cos b, you can see the formula cos a cos b equal to 1 by 2 into cos a plus b minus cos a minus b. By using this two a terms, a square is taken out. When we are converting this cos a cos b, 1 by 2 will be there, so it is replaced as 1 by 2. So here cos, this is a and this is b. So cos a plus b. So we will be having, you can see here the two terms will be there. So 2 omega naught t plus this omega naught tau plus here 1 theta, here 1 theta. So 2 theta plus cos. Next is a minus b. When you make it as a minus b, this is a term, this is b term. So omega naught t minus omega naught t gets cancelled. Next theta minus theta gets cancelled. This minus omega tau will alone be here. Okay. In the next term, this is cos minus theta is cos theta. Okay. So this becomes cos omega tau. Now collect all the constant terms. Here the variable is theta alone. So this cos omega tau comes out. So a squared by 2 cos omega tau, it's a constant term. Next is a squared by 2 expectation of this cos term alone. So you can cos 2 omega t plus omega naught t plus 2 theta into 1 by 2 pi d theta. This we find out this probability value since it is given as uniformly distributed. We calculated the probability function using this distribution function. Okay, d theta. Now you take this 1 by 2 pi outside. So we will be having a square by, when you take it out, this becomes already 1 2 is there, so 4 pi. What is remaining? Cos 2 omega naught t plus omega naught t plus 2 theta, right? So this integration of this cos becomes sin 2 omega t plus omega naught t plus 2 theta. Since we are integrating with respect to theta, the constant term 2 comes at the denominator, so divided by 2, 0 to 2 pi. Okay. Now when you substitute the limit, this term get vanished. You will be having only this a squared by 2 cos omega tau. This gets vanished. So you compare this autocorrelation function which has only tau, which depends only on tau. What is tau? Tau is nothing but time difference. Hence x of t is WSS process because the mean value is constant and the autocorrelation function is dependent of only time difference. So we call it as WSS process. Okay. Next we will go with another problem